Hi, my name is Riley Krudop, and for my research, I studied anthropogenic impacts on Midwestern water quality.
Okay, so just as I said, for my research, I studied Midwest water quality and anthropogenic influence. So during my research, some of the key pieces were about location based environmental impacts and water quality parameters. And location based environmental impacts are basically the various environmental impacts caused by humans on water quality in rural, suburban, and urban locations. And water quality parameters include both pollutants and indicators of water quality. So, I first studied urban environmental impacts and found that most anthropogenic or human caused water pollution comes from heavy metals and air pollution, according to a book entitled Urban Runoff Pollution. In suburban settings, most pollution comes from fertilizer, from runoff, and from wastewater treatment runoff. And this is according to a peer-reviewed study by the Journal of Science and or of the Total Environment. And in suburban environments, it would be expected that there are higher nitrogen and phosphorus concentrations, while in the urban environments, because most of the pollution comes from heavy metal, it is not expected to demonstrate higher levels of pollution. For the rural area, according to two environmental professors, agricultural runoff is the main source of pollution, and like the suburban runoff, this would also show high concentrations of nitrogen and phosphorus, except in larger amounts because the runoff is so much greater. So my hypothesis was that rural locations would demonstrate the highest amount of, or the poorest water quality. So my the water quality parameters studied were phosphorus and nitrogen, and these two are pollutants, and they often cause eutrophication, which is excessive algal bloom, and this is caused by high concentrations of those two, and the excessive algal blooming actually cuts off the oxygen from fish below and kills any organisms living in the water. And dissolved oxygen in too high or low concentrations does the same thing. Nitrogen and phosphorus mainly enter lakes from in excess from agricultural fertilizers and municipal wastewater discharges, which, as I said earlier, is more similar to what happens in rural and suburban settings. For dissolved oxygen, it mainly comes from dead organic matter, and in increased temperatures, it can increased temperatures decrease water's ability to hold dissolved oxygen. The average increase in temperature due to global warming can be harmful to many organisms because they will not be able to survive in different habitats. And increased pollution of carbon dioxide in the atmosphere also increases the pH of the water, and this can be, again, detrimental to species' survival because of these new environments that they are not adapted to live in. So all of this research was primarily based on multiple peer-reviewed studies on water quality and pollution, and led me to my research question. How do the effects of potential anthropogenic water quality parameters differ in rural versus suburban versus urban settings? So in my research, I used two different methodologies that went hand in hand with the study, experimental and case study. And the case study was just, I was studying the one case, and how I conducted this was I went to each of the lakes and I collected various water samples, and I had 3 trials of each test with one control also, and the control was deionized water, which has no extra nutrients in it, so it should serve as a baseline or at least a comparison. And I tested these with respective water quality kits. So I had a nitrogen kit and a phosphorus kit that I used, and then I graphed my data. So the results for Lake X, my rural lake, demonstrated significantly more phosphorus and nitrogen and carbon dioxide than the control of deionized water, but the pH was relatively similar. In Lake Y, my suburban lake, it only had higher phosphorus and nitrogen concentrations, while the carbon dioxide and pH were rather similar to the control. Lastly, in Lake X, my urban lake, it was similar to Lake X because carbon dioxide, phosphorus, and nitrogen were much higher than the control, while the pH was relatively similar. So when comparing the phosphorus levels of all 3 lakes to the acceptable levels from the Illinois Nutrient Science Advisory Committee, lakes Y and Z are significantly greater, while Lake X, my rural lake, was about the same, which was interesting because this is not what I anticipated. In terms of nitrogen concentrations, while rural was the greatest, it also had the largest standard deviation, which is what the error bars indicate. So the only lake that actually had a significant difference to the acceptable concentration was the urban lake. My carbon dioxide did not have an acceptable concentration to compare to because it is a trace chemical and mainly just increases pH by forming calcium carbonate, but it should be noted that Lake X had the highest concentration. Also, all of the lakes were within the acceptable pH range and were very similar to each other. It should also be noted that the pH test only went to 7.6. However, the rural lake is the only lake that looked like it had a 7.8, so this did not impact the results too much. Again, as I reach my limitations, implications, and conclusion, I want to remind you of my question. How do the effects of potential anthropogenic water quality parameters differ in rural versus suburban versus urban settings? My research did have some limitations, and this included the temperature and dissolved oxygen. So, due to weather, all of my temperature results were near freezing because all of the lakes were partially frozen. If you were paying attention as I went over the picture, or I will scroll back to them, but my pictures of the lakes that I took, you can see that the lakes are almost completely frozen over. So the temperature that was recorded did not indicate any global warming or pollution causes because of the season. Also, due to either faulty equipment or due to the cold temperatures that allowed the water to hold higher concentrations of dissolved oxygen, all of the results for dissolved oxygen read over range. So these 2 results did not signify anything in terms of my conclusion to this research. So one reason my results could have been different from my predictions was because all of the data was collected during winter, and during winter there is no, in the Midwest, there is no agriculture occurring, or there's no fertilizers being used on lawns in suburban areas, so this could be the reason for the lower concentrations of nitrogen and phosphorus in the lakes in the rural and suburban areas. Finally, because I only had one of each lake type, the results could be lake specific rather than location based. So the implications of my research include that Lake X was right next to a wastewater treatment plant. So this could be, the water in the lake could be from the runoff, or it could be the cleaned water that they're pumping out of the wastewater treatment plant. So the results could be indicative of how well the plant is cleaning their water or the water that gets away. Also, Lake Y is indicative of runoff mostly because it is filled by rainwater. And in Lake Z, there were motorized boats on this lake, so there could be unanticipated sources of pollution that my research did not initially anticipate because the other lakes did not have motorized boats on them. So also, urban had the greatest levels of pollution of the pollutants nitrogen and phosphorus, which is, as I mentioned earlier, the opposite of what I anticipated, and this could have been caused by the season. Lastly, as I will touch on later, future research is required for more conclusive results. So my conclusions from this study were that this research could be useful to scientists because they can build off it and study different things, and this could prevent them from redoing my research, which would only waste time. And it could be useful to people in local governments because it will highlight what needs improvement and what they can change to help their environment. Also, of the lakes, Lake Z would most require a needs assessment, as I will touch on later. In the future, if given 6 more months, a continued study of the same lakes to see how seasonal human habits impact the water quality parameter levels would be useful to test my conclusion of the seasonal impacts being the reason why my hypothesis was off. Then I could know if while it is the peak seasons for agriculture, if rural lakes demonstrated higher levels of nitrogen and phosphorus, and same with suburban. If given 2 more years, in addition to seasonal analysis, more lakes would be included in the study to gather averages and trends of the locations. And lastly, a needs assessment should be performed on Lake Z because of its high concentrations of nitrogen and phosphorus compared to the acceptable levels. This is my bibliography of all the sources I used in this presentation. Not all of the sources I used, and thank you.
Thank you for listening to my presentation, and if you have any questions, you can comment them below. From my research, I would like to highlight that of the lakes studied, Lake Z, my urban lake, had the highest concentrations of water quality parameters and pollutants, and I anticipate that this was because of the season the results were recorded in, which in the Midwest there is no agriculture occurring because it is winter. Thank you so much.